Let's practice this 4 integration by substitution problem. Another name for this technique is called u-substitution. So starting from the first one, we have 6x minus 12 divided by x squared minus 4x minus 7. So the first step is I decide to let u equals to the denominator. So x squared minus 4x minus 7. When you have a rational functions like this, we usually let the u be the denominator, and then you take the derivative of that is a 2x minus 4 dx, isolate dx on one side, 1 divided by 2x minus 4 du equals to dx, and then you perform the change of variable. So what you have to do is you will have to put this dx over here, so that is called the change of variable, and then you have integral the 6x minus 12. I suggest you to factor out a 3, so because once you factor out the 3, you have a 2x minus 4 on top. Do you see that? When you distribute the 3, you have a 6x minus 12. The denominator is now a u, and then the dx becomes multiply 1 over 2x minus 4 du. So this is a du integral. That means all the x must be gone, so we get rid of the 2x minus 4. So now you have a 3 over u, which is simple, right? So then this is what is the integral of 1 over u? The integral of 1 over u, not a power rule, that is ln. So we have a 3 absolute value ln of u plus c, and then the u, you let that equals to the denominator, so that is 3 times ln absolute value of x squared minus 4x minus 7, and then close the absolute value plus c. Now, is the absolute value optional? The answer is no. The reason is ln of negative is undefined, so you have to use an absolute value to get rid of the negative. Now, there is a what if. So what if just a what if you have a x squared minus 4x plus 7? If you have that, then the solution is, you can get rid of the absolute value. Then the solution is 3 times ln parenthesis x squared minus 4x plus 7. Do you know why? Because if you check out the graph, so since x squared minus 4x plus 7, that is always greater than 0. So if you check out the graph, this function is above the x-axis. Above the x-axis means y is greater than 0 at any time, so there is no need to use the absolute value. So the most confusing thing is when you do your homework online, if the absolute value is required and you did not put the absolute value in there, the system will just mark your entire problem wrong. So this is a very serious matter. How do I know? Because I lost point for this absolute value. I still remember I was doing a big problem in the computer lab. I was using my math lab. I checked my answer like 10 times to make sure there is no mistake, but the system still say that this is an error. And then I consume all my attempts, and then at the end of the day, I find out that the problem was the absolute value. So I learned my lesson. Okay, so be careful with this. Absolute value is always required. The only situation where you can change that to a parenthesis is the function is absolutely positive. All right, so that is the first problem. And then the second problem, I would like to do the orange problem. So that problem has a hidden step. So the first step is we will let u equals to the radicand. Second problem right here. So 3x squared plus x, and then times 1 minus x. I'm going to let u equals to the radicand. So I'm going to let u equals to 1 minus x, and then du equals to negative 1 dx, and then you have 1 over negative 1, right, which is negative 1 du equals to dx. So when you do the change of variable, so plug in the negative 1 du over there, you will see that that is not going to get rid of the 3x squared plus x. So that means if you insist to write everything out, you won't be able to integrate any further because you have a du integral, but you still have an x in there. So at this point, we will have to figure out the hidden steps. So here is the hidden step. This can be a very popular exam problem. So this thing is so popular on exam. So the hidden step is, so right here. So you are going to tell me what x equals to. So this x is equals to, what is that equal to? 1 minus u, right? And then do you see that there is a 3x squared? So what is x squared equals to? X squared is you square both sides. And then how about 3x squared? Then you multiply both sides by 3. So 3x squared equals to 3 times 1 minus u squared. And then the x you have that in the very first line. Now, you are going to do the change of variable. So we are going to start with the integral. So we have an integral 3x squared plus x. I want to match the color code for you because that will make everything so much easy to read. So this is a 1 minus u squared. That is your 3x. And then you plus x. So you plus 1 minus u. And then this is the 3x squared plus x. And then you have the whole thing, you multiply the square root of 1 minus x, which becomes the square root of u, right? So I'm going to change that to u to the 1/2 du. Did I miss anything? Can you tell me that? Did I miss anything? The answer is yes. So what is dx equals to? Dx equals to -1 du, right? So that means I miss a -1. All right, so I'm going to erase this du and then put a -1. So this is a all multiplication and then a du. So what you are going to do next is you will have to fully open up the square. So clean this up and then you distribute the x to the 1/2. All right, let's do that. So we have an integral. So after you clean that up, so first of all, you will have to use 1 minus u times 1 minus u. And then you distribute the 3 and then you plus the 1 minus the u. So after you did all of that, so I would just skip that line because this is a calculus course. I expect you to be able to do the algebra. So what I got is, after the simplification, inside the square bracket, I have a 4 minus a 7u plus a 3u squared. Again, you take 1 minus u times 1 minus u, you open up the two factors, distribute the 3, and then you plus 1 minus u. And then you got that, and then you will have to distribute u to the 1/2, and then you have a -1 du. We do the -1 at the end, and then this one gives me what? Let's just pull the -1 out. So that one gives me a 4 times u to the 1/2 minus 7 u to the 1 plus 1/2, that is a 3/2, and then plus 3 u, 2 plus 1/2, that is a 5/2 du. And then now you can integrate. I know you have a -1, so let's put this, use a big parenthesis, u to the plus 1, right? 3/2, reciprocal is 2/3, so 2 times 4 is 8. You have 8/3, take the derivative of that, you get back to the integrand. And then u plus 1, 5/2, reciprocal, 2 times 7 is 14/5. And then plus u plus 1, so that is a 7/2. Reciprocal is 2/7. 2 times 3 is 6. 6/7. And then that's it. Okay, what else do we have to do? We will have to distribute the -1 and then put the x back, right? So we have a negative 8/3, and then the 3/2. I will just use a square root, and then the third power, we put the third power inside, and then plus 14/5, and then here is the square root, and then we have the fifth power inside, and then minus 6/7, minus, right? So minus plus minus 6/7, and then here is the square root, and then you have the seventh power inside. And then don't forget that there is a plus c. So what goes inside the parenthesis? Did you let u equals to 1 minus x, right? You wrote that at the very beginning, u equals to 1 minus x. So let's put it back in. So 1 minus x, 1 minus x, 1 minus x, and then 1 minus x. All right, so that is the answer to the second integral. And then the third integral, we have the integral in green. So we have an integral ln 3 x squared. So this one, you cannot bring the 2 down. once again, you cannot bring the 2 down to the front of ln because this one is you evaluate ln of 3x first and then you square the result. You cannot bring the 2 down. When can you bring the 2 down? If you have ln 3x squared. So when you square the 3x first and then you take the ln, in that case you can bring the 2 down to the front, but in this case you cannot. Once again, you cannot bring the 2 down to the front. Okay, I will copy these 2 problems for you so you don't need to take any screenshot or rewind the video. I use screen, right? So we have integral ln 3x square the entire ln divided by 5x. This I will just let u equals to ln 3x. So ln 3x du is equals to, so 1 over 3x by chain rule, the derivative of 3x is equals to 3, and then the 3's got cancelled, then you have x times du equals to dx, and then this is a dx. The change of variable, we will put this piece over there, so the x will be cancelled in the denominator, and then you have an integral u to the second power divided by 5 times x, the dx is x du, and then you get rid of the x, you have 1 over 5, and then a u square, right, du. So this becomes a very simple power rule, and then you have u to the third power, you have a 1/3, I 5. You have a 1/3, and then you have your 1/5, and then you add a c to it. So this is equals to 1 over 15, and then u is ln, right? So you have a ln 3x raised to the third power plus c. Once again, you cannot bring the 3 down to the front in this case. Alright, so that is the third problem, which is way easier than the second one. And then let's move on to the last problem. The last problem, I use what color? I use blue. Okay, I will follow the color code. So the last problem is you have integral e to the square root of 3x divided by 2 times square root of 3x dx. Okay, so we have this inside the exponential function. I am going to let u equals to the square root of 3x. So du is going to chain rule, right? So bring the 1/2 down, and then 1/2 minus 1, and then the derivative of the radicand is equals to 3 dx. So this is a du equals to 3 over 2, and then square root of 3x dx. Isolate the dx on one side, we have then that will be a reciprocal, right? So 2 square root of 3x divided by 3, and then you have a du equals to a dx, and then we do a change of variable. We will put this dx over here, and then we will get rid of some stuff, and then you have integral e to the u divided by 2 times square root of 3x, and then you multiply the replacement 2 root 3x divided by 3, and then very happy we get rid of these 2, and then look how easy it is. So this is the integral of e to the anything, is always e to the anything, right? So we have a 1/3, integral of e to the u is still e to the u plus c, and then we put the x back. So once we put the x back, that is 1/3 e to the square root of 3x plus c, and then this is the final answer. Now, this problem looks very easy, and there is one thing that you should not do. So I'm going to do this in red. So if you go this way, you will get a 0. So do not do that. So do not let u equals to e to the square root of 3x. So let's see what happens if you insist to do so. Then you have a du, again, e to the anything is e to the anything. And then by chain rule, you take the derivative of the exponent, that is a 1/3 3x, and then negative 1/3, another chain rule, you get a 3 dx, right? So that means you will have a du equals to, what do you have? That looks complicated. You have a 2 square root of 3x, and then a e right here, and then multiplied by 3. I will just put the 3 in front, and then you have a dx, and then you will have a reciprocal, so you have a 2 square root of 3x, and then a 2e square root of 3x du equals to dx. All the derivatives are correct, but when you do the change of variable, there is going to be a big problem. So back to this problem, then you have integral, right? Then you have integral. So you let the numerator be the u, then you will have a u divided by 2 times square root of 3x, and then you multiply 2 times square root of 3x divided by 3 e square root of 3x dx. All right? Do you see that? And then can we rewrite this a little bit? Of course. So first of all, you will get rid of the 2 times square root of 3x, right? And then there is still an x right over here. So there is one little mistake that I made is this is not a dx integral anymore. This is a du integral, right? So this is a du integral. How do you get rid of that dx? Cancellation is not going to work. Now, I am going to go check this out. I let u equals to this guy at the very beginning. So that means I can just do that. I'm going to erase this e to the square root of 3x and then just put a u in there. So everything looks right? So everything looks very reasonable and looks very correct. And do you see that what's the problem? So we got rid of two big stuff, and then you have a u and then a u. So what happened? Then this becomes integral 1/3 of du, and then you have 1/3 of u plus c, and then what is u equals to? So u is equals to 1/3 and then e to the square root of 3x plus c. Now answer these questions for me. Is this equals to what we just got? Can you compare this to the blue answer? They look exactly the same, right? Do you still remember that I said that if you do this on the test, you will get a 0? Now, that's why. So do you see that this actually catch your attention? So if you do that, you will get a 0. But the thing is, I did all the work, I am still be able to get back to the answer. Why do I say don't do this? Because when you are doing this, this might scare half people away. That's the reason why I take this problem for our discussion. So everything looks right. So you let u equals to that, you take the derivative, you isolate dx on one side. The problem is what scares people away is this line. Do you see that you get rid of the 2 times the square root and then you get rid of the u, right? So once people get rid of the u, they might be thinking, all right, so there is an e to some power in the original, in the integrand, right? You get rid of that. So since the e is gone, there is no way to get the e back. So the reason why I put this out is because of this line. The e is gone. So you are thinking, all right, so since the e is gone, there is no way to get it back, then I should not do this. But the answer is no. If you do it carefully, do you still remember that I replaced this by the u? So if you do the math carefully, you can actually get to the right answer. So do not do this. So now we can fix our discussion. Just remove the do not let u equals to this. You can let u equals to this, but in the middle of the test, when you do your homework and your quizzes, I don't recommend you to go this way because I don't want you to get stuck at this step. This is right, but that might scare people away. So it is right, but that might make people think that it is a mistake if you do not do the calculus carefully. So yes, this is still good to learn, but give yourself a warning. In the middle of the test, especially when the problem worth so many points, I would not play any tricks on the test. So what I will do on the test is I will just follow the blue procedures. All right, the red, good to study. That's why I choose this problem. But just keep that in your mind. Don't play anything funny on the test. Just follow the blue one. Okay, so that is the end of this video. If you like the problem I create, if you like the discussion I provide, give me a thumbs up, a subscribe, and I will see you all in the next video. Signing out.